Welcome back to the lecture series of network theory. In our last class, we have learned about supermesh and we have also simplified electrical network using that concept. And as I said that supermesh and supernode is an important concept in electrical circuits. In today's class, we will be learning about supernode. So first we have to know what a supernode is. A supernode is a concept in electrical circuit when we have a voltage source between two nodes. So we can say this is a concept of a bigger node. So let's get started.
Now, if we look at this electrical network, we suppose if we want to find out the voltage drop across this 4 ohm resistor, then how we can find out that? Now, if we closely analyze this circuit, we can see that we have here one mesh. Here we have 2, 3, and then 4 meshes. And if we analyze the circuit with respect to node, then we can see we have one node, principal node here, another principal node here, another node here. Now if we connect, suppose if we connect this node to the ground, so this node can be taken as a reference node. So that means we have two more principal nodes where we can apply the concept of KCL. So in this circuit we have 4 meshes and 2 principal nodes. So we will go for node analysis since the number of nodes are less than number of meshes. Now if we want to apply the concept of node analysis, what we have to do is at this principal node we will apply a potential or voltage value. Suppose this node is A, so this will be VA, and suppose this node is B, so the voltage value of potential of this node will be assumed as VB. Now at this node, if we want to apply the concept of KCL, we can see that here we have 4 branches associated with this node. So the current source, already the direction of this current value is given, and with respect to this node, that is incoming current. And for other branches the currents are not given, so we'll assume that the currents are leaving this node. Now if we apply the concept of KCL here, then we know that summation of all the incoming currents will be equal to summation of all the outgoing currents. So incoming current is 2 here, so 2 will be equal to, suppose for this branch the current value is I1, and for this branch the current value is suppose I2. So it will be 2, which is incoming current, and that will be equal to summation of all the outgoing currents. Now for this 2 ohm resistor, the current that is flowing is through this 2 ohm resistor is the potential difference between these 2 points. So this will be connected to ground, this node. So it will be VA minus 0 divided by 2. So this is the current value, and for these 2 branches, suppose this is one current I1 which is leaving this node, and for this branch also I2 which is leaving that node. So with respect to this node, this is the equation that we have formed. Now if we come to the other side and if we apply, this was at node A. Now if we apply KCL at node B, we can see here that we have a current source, and the direction is given. With respect to this node, the direction is leaving this node, and for others, for this branch it is not given, so we'll assume that the current is leaving. And for these 2 branches, the currents which have already assumed that this was leaving this node, so they are coming back to, they are coming to this node, and this time they will be incoming currents with respect to this node. So this can be easily written like I1 plus I2, that will be equal to this summation of these 2 currents which are leaving this node. So this current value is already given in the circuit, which is 4, and for this 4 ohm resistor the current value will be VB minus 0, because the potential of this node is also 0 volt. This is also reference, these 2 nodes are same node. So VB minus 0 divided by 4, that means 4 plus VB by 4. So we can easily see here that I1 plus I2, this value is basically VB by 4 plus 4. So this is our second, though this is our second equation, but we can replace this value in our first equation. So if we replace that, then it will be 2, and that will be equal to VA by 2. And then in place of I1 plus I2, we can easily easily replace this summation, this value, and we can write this value 4 plus VB by 4. So this will be our new equation, or you can say this is our third equation, where we'll have these two variables VA and VB. Now if we simplify this, it will be 2, and then if we simplify this way, then it is 2VA plus 16 plus VB. So finally the equation that we'll be getting is 2VA plus VB, and that will be equal to 16 here and then 8 here. So it will be minus 8. So this is our, say, another equation if we name this as. Now if we come to the actual original electrical network, what we can see is we have a voltage source here between these two nodes. So as per the concept of super node, this will form a super node. So what we have to do is we have to deactivate this voltage source by shorting that part. We will assume as if that voltage source is not there. So this node A and this node V together will form a bigger node, and that will be the super node. So if we redraw the circuit, then it will look like this. So as if the voltage source is not there, and this A and B between these two nodes, there is a shorted path. So from the concept of if we suppose think that there is a shorted path, and we know that voltage drop across a shorted path is 0. So if we think this way, that VB minus VA, that will be equal to 0, because we have already assumed the potential of this node is VB and potential of this node is VA. So VB minus VA, that will be equal to 0, because we have now assumed this as a shorted path. So VB will be equal to VA. So we can think that these two nodes are basically the same node, so they will form a bigger node. And if we go by that concept, then we can rethink of the currents that are flowing with respect to that node. So with respect to this node, we have already seen that this 2 ampere current was flowing, that was the incoming current with respect to this node, and this was the outgoing current that we have already assumed in the original circuit. So with respect to this node B, the current was leaving with respect to this 4 ohm resistor, and the direction of this current source is already given, that is again leaving with respect to this node. This is incoming. Now what we will do is we will think these two nodes as a bigger node, and at that node we'll apply KCL. So at this node, what we can see is we have 4 branches. So if we go by the direction of the currents of these 4 branches, then the new equation that we will get is, here it is incoming current, this is outgoing, this is outgoing, this is outgoing. So all the summation of all the incoming currents, so it is only, we have here only one incoming current, so that will be equal to 2, and outgoing currents are, here it is VA, the potential, here it is VB. And one thing here also has to be noted, that when we consider supernode does not introduce any extra potential. So whatever potential values for individual nodes we have assumed in the original circuit, that will be maintained while forming the equation by applying the concept of supernode. So here the potential of this node will be taken as VA, and potential of this node will be taken as VB, and based on those variables we will be forming the new case equation by applying the concept of supernode. So here when we will be finding out the current value through this 2 ohm resistor, it will be VA minus 0 divided by 2, and this is incoming current, so it will be VA minus 0 divided by 2, and for this resistor it will be VB minus 0. These are reference nodes, so VB minus 0 divided by 4 again, and then the current value through this current source, which is again leaving, so it will be 4. So if we simplify this equation, it will be VA by 2, then VB by 4, and then plus 4. If we simplify further, then it is 4, so it will be 2VA plus VB plus 16. So if we rearrange the terms, it will be 2VA plus VB, and that will be, here 16 we have, and here my 8. So when it will come to the other side, it will be minus 8, and that is our first equation that we have developed by applying the concept of supernode. Now if we compare this equation with the equation that we have already derived, Without applying the concept of supernode, the equation that we obtained was 2va plus vb is equal to minus a, and here also we have obtained the same equation. But here, when we applied the concept of supernode, we obtained this equation in less time. So that is the advantage of applying the supernode. We are getting the same equation. Now, since we have two variables va and vb, so for to get the values of va vb, we need to have another equation. So if we go back to the original circuit, we see that between these two nodes or between these 2 points, the voltage, one voltage source is connected, and the value of that voltage source is 10 volt, and positive terminal is connected to B point and negative terminal is connected to node A. So here we will apply the concept of KCL, or even directly also we can write here that this is at the higher potential with the point B, and this is at lower potential, so it will be VB minus VA, that will be equal to 10. So the second equation will be between A and between B. This is VB and this is VA, and the voltage source which was connected, that value was 10. So we can write that VB, which is at higher potential, that will minus VA, that will be equal to 10, and that will be our second equation. Now if we simplify further these two equations, we can find out easily the values of the variables. So if we multiply this equation by 2, the new equation that we'll be getting is 2VA minus 2VB minus 2VA, and that will be equal to 20. Now if we write the first equation here, so it will be VB plus 2VA, and that will be equal to minus 8. Now if we simplify this 2, it will be 3VB, and that will be equal to 12. So VB will be 4 volt. Now what was expected from us was voltage drop value across this 4 ohm resistor. So 4 ohm resistor voltage drop is VB minus 0, that is the voltage drop. That means VB we have found out, so the voltage drop value will be 4 volt only.
Now in this circuit we have to find out the current value which is flowing through 3 ohm resistor, that means this resistor. Now in this circuit, if we analyze, we can find that we have three meshes here. This is one mesh, this is one mesh, and this is another mesh, the third mesh. So in this circuit we can, from this circuit we can form three meshes, and if we analyze the nodes, here we can see that we have one principal node here, another node here, another node here, and we have another node here. Now if we connect this node to the ground, so this will be taken as a reference node. So apart from this, we still have three principal nodes where we can apply the node analysis or KCL. Now, so in this circuit we have three meshes and three nodes, and since we are learning here the concept of supernode, so we will go by the node analysis. Now if we go by the node analysis, so what we have to do is, first at the principal nodes we say, first I will mark the principal nodes as A, this node as B, and this node as C, and I will assume the potential of every principal node. So this potential of this node, say, let's say this is VA, this is VB, and this is VC. Now we can see that between node A and node B there is a voltage source. So these two nodes will form a super node, and as we know that supernode doesn't contribute to any extra potential. Whatever potential we have assumed for these individual principal nodes, they will be followed in case of forming the equations by applying KCL. But these two nodes, since there is a voltage source, so that these two nodes can form a supernode. Now here on the other side of that circuit, we can see that between C point or C node and between this reference node, we have again a voltage source. So it may seem that it will form a supernode, but the concept of supernode is, the supernode is formed between two non-reference nodes. So in this case, this node A and node B, these two nodes are non-reference node. That's why these two nodes will form a supernode. And in this case we have the C node is the non-reference node, but this node is, since it is a reference node, so these two nodes will not form any supernode here. So if we apply KCL at node A, or maybe we can write at supernode, which is between A and B, if we apply the concept of KCL, then we can see here at this node the two branches which are connected is this branch and this branch, and at this node the branches which are connected is this branch and this branch, and we will ignore this voltage source in this case. So the current directions are not given for the registers, so we will assume that all the currents are leaving that particular node. So in case of A, this two, the currents which will be flowing through these registers, they will be leaving. Again, with respect to this node also, the current directions are not given, so we will be assuming that these currents are leaving that node. So that means with respect to this super node which is formed taking A and B, all the currents are leaving. And if we go by the concept of KCL, then it says that summation of all the incoming currents is equal to summation of all outgoing current that we already know. In this case, there is no incoming current, so we will first write all the outgoing currents, we will sum them up, and then that will be equal to 0 since there is no incoming current. So through this branch, the current that will be flowing is since we have assumed that the current is leaving this node, so A is at higher potential as per our assumption and C is at lower potential. So the potential difference will be VA minus VC divided by the resistance value. If we divide by that value 2 ohm, then we will get the current value through that path. So VA minus VC divided by 2 ohm will be the current value. Now if we consider this branch or this resistor, then this is at higher potential as per the assumption of the current direction, then and 0 is at lower potential with respect to VA. So the current value will be the potential difference means VA minus 0 divided by the resistance value of that path, and this will be added because this current is also outgoing current with respect to that node, so it will be simply VA divided by 3. Then the other node of that super node is B, and their branches are this branch and this branch, and current, if we find out the current value through this branch, it will be as per the direction of this current, it will be B will be at higher potential and C will be at lower potential. So current value will be VB minus VC, this is the potential difference between these 2 points, divided by the resistance value, and it will be again added as this is also leaving, and this current flowing through this 4 ohm resistor will be VB minus 0 divided by 4. So it will be VB minus 0 divided by 4, and summation of all these outgoing currents will be equal to 0. Now this is one equation that we have found by applying KCL at super node, and in this equation we have 3 variables which are VA, VB and VC. To simplify this equation and to finally find out the values of these potentials, we need some more equations. It will be helpful if we can form 2 more equations involving VA, VB and VC. Now let's see how we can form other equations. Now if we look at this part of the circuit from where we have formed the super node, we see that the both sides of this voltage source, this is A and B, and their potentials as per our assumption is V and VV, and since the positive terminal is connected to the A point and negative is connected to the B point, so we can say that VA is a higher potential and VB is at lower potential with respect to this voltage with respect to the polarity of this voltage source. So we can write that VA minus VB, which is the potential difference between these 2 points, and there between these 2 points this voltage source is connected whose value is 5. So VB minus VA minus VB, that will be equal to 5. So this was our first equation, and this can be said as our second equation which has 2 variables VA and VB. Now if we come to this side of the circuit, we can the same by going by the same concept, we can see or say that VC is at higher potential and 0 will be at lower potential because the positive polarity of this voltage source having value 10 volt is connected to C. So here from this part of the circuit we can say that VC minus 0, that will be equal to 10. So that means we can write that VC will be equal to 10 volt. So one of the variables is already found out. So now in the first equation, if we put the value of VC, it will be VA minus 10 divided by 2 plus the second term is VA by 3 then the next term is VB, then minus 10 divided by 1, and next we have VB by 4, and that will be equal to 0. If we simplify this equation, and here in this equation we have now two variables VA and VB, and in the third equation we have again, in the second equation we have again VA and VB. So easily now we can simplify these two equations and we can find out the values of VA and VB. So if we simplify this equation, finally the equation we'll be getting is, in the denominator we'll be having 12. If we go by the simple concept of mathematics, then it will be 6VA minus 60, then it will be 4VA plus it will be 3VB, not 3, it will be, here we have 1, so it will be 120 VB, it will be 12 VB minus 120, and then it will be plus 3 VB, and that will be equal to 0. So if we simplify further, then we can see VA 10 VA 6 VA plus 4 VA, so it will be 10 VA, then we have 4 VB 12 VB, so it is 16 VB, no, this is VA, so 12 plus 3, it will be 15 VB plus 15 VB, and we have minus 60 minus 120. Now if we take on the other side, it will be plus 180. So this will be our fourth equation, where the equation is 10 VA plus 15 VV is equal to 120, and we have already this equation, the second equation, where we have VA minus VB is equal to 5. Now if we multiply the second equation by 15, or maybe the equation if we multiply by 10, then it will be, the modified equation will be 10 VA, then it will be minus 10 VB, and then it will be plus 50. So this is our, this can be called as our fifth equation. And if we solve these two equations, then finally from here, 10, the VA will be will cancel each other, so what will remain is, in the finally from that solution, it will be 25 VB, and that will be equal to 130. So we can say VB will be 130 by 25, and that will be definitely volt. And now from the second equation we have this relation VA is equal to 5 plus VB, right? So easily we can find out the value of VA, that is 5 plus VB, which itself is 130 divided by 25. So it will be 125 plus 130, so it will be 255 by 25, that much volt. But what was expected from us was the current value which is flowing through 3 ohm resistor, and that is VA minus 0 by 3, so VA by 3. So the current value which is flowing through 3 ohm resistor, that will be equal to VA divided by 3. So it will be 255 divided by 25, and this 25 will be multiplied by 3, and if we simplify, this value will come as 3.4 ampere. So this is the final answer, which this is the current value which is flowing through this 3 ohm resistor. And this is the way how we can simplify a circuit where we have a voltage source between two nodes, and how we can, by applying the concept of supernode. So this is the end of this class. Thank you.